A cat slips from a height. For an instant, its body is not ready. Its paws are not below it. Its back is twisted. Gravity is pulling it down. Then the cat begins to move. The head turns. The spine bends. The front legs fold. The rear legs stretch. The front half and rear half of the body rotate in different ways. Before the cat reaches the ground, it has turned itself into a landing position. It looks as if the cat has pushed against empty air, but that is not what happens. The cat is solving a problem in rotational mechanics. If a rigid object is falling with no rotation, it cannot simply turn itself over without an external torque. It would need something outside itself to push against. But a cat is not rigid. It has a flexible spine, movable legs, and fast reflexes. It can change its shape while falling. The total angular momentum remains nearly conserved. The cat does not create rotation from nothing. Instead, it rearranges its body so different parts rotate in opposite directions and by different amounts. The front half may turn one way while the rear half turns another way. Then the cat changes its leg positions and reverses part of the motion. Step by step, the whole body changes orientation while the total angular momentum stays balanced. This is called the falling cat problem. It became famous because it challenged simple ideas about rotation. A falling cat shows that orientation can change even when total angular momentum remains zero if the body is flexible enough. The cat first senses direction using the vestibular system in the inner ear. This tells it which way is down. Then the nervous system triggers the righting reflex. The head turns first. The front body follows. The front legs may pull inward, making the front half easier to rotate. The rear legs may extend, making the rear half harder to rotate. Then the pattern changes, allowing the back half to align. The result is a coordinated midair turn. There is a common misconception that cats survive falls simply because they always land on their feet. That is not true. The righting reflex needs time. If the fall is too short, the cat may not have enough time to complete the turn. If the fall is too high, landing feet first may still not prevent injury. Speed, surface, body condition, and luck all matter. Landing posture is only one part of survival. The cat also uses its body to reduce impact. It spreads its legs, flexes its joints, and uses muscles to absorb energy. The paws, legs, shoulders, and spine act like a biological suspension system, but the impact is still real. The most important lesson is that the cat does not break the laws of physics. It uses a loophole available to flexible bodies. A rigid body cannot easily reorient itself in midair without external torque. A flexible body can change shape. By changing moment of inertia in different body parts, it can rotate internally and still keep total angular momentum nearly unchanged. That is why the cat's motion is so strange and so precise. It is not magic. It is not flight. It is controlled deformation. A falling cat turns because its body is not a single solid object. It is a coordinated system of spine, legs, reflexes, and physics. And in the brief time before the ground arrives, that system reorganizes itself for landing.